a simple problem from differential equation, and problem says that the order and degree of the differential equation whose general solution is given by this, okay, where a and b are arbitrary constant. Clearly from the given solution, two arbitrary constants are contained in this solution. So we know that the order of the differential equation must be 2. So our answer must be either A or B. Okay. Now if we try to find out the differential equation from the given solution, this is equation number, or we write here the equation again. This is ax square plus by square, this is equal to 1. We name this is 1. Differentiating we get this is 2ax plus 2by1, this is equal to 0, or we cancel out 2 from this relation, we name this is 2. And the third one is again differentiate this, we get a plus b into y1 square plus y2, this is 0. This is relation number 3. Now to get differential equation, we eliminate AB from 1, 2 and 3, and by very easily using determinant, this is x square, this is y square, this is 1, this is x, this is y1, this is 0, this is 1, this is y1 square, this is y2, this is 0. Okay, and clearly by expanding with respect to third column, we get the differential equation as x into, this is 1 into this, and this are deleted, this is x into y1 square plus y2 minus y1, this is equal to 0. This is the differential equation, and clearly the power of the highest order derivative y2 is 1. Okay, so we say that the order is 2 and degree is 1, because the power of y2, this is 1 here. Okay, so our correct option is, if it is said that it is linear or non-linear, then it must be non-linear, because here y1 square and y1 appear, y2 appear. That is the product of dependent variable appear, or power of dependent variable is 2, so this is must be non-linear, but it is degree 1 and order 2. So our option D is correct. Okay, very simple problem from the basic property of differential equation. Thank you for watching.